Hello everyone, welcome to Logic Binder. In today's video, we'll learn about the introduction concepts of formal languages and automata theory. Now let us discuss about the basic definitions. Automata theory. It is defined as the study of abstract computing machines called automata, which is a mathematical machine or a model of computations. In simple words, the automata theory helps us how a machine reads the input, how it implements the logic, and how it decides whether the input is valid or invalid. Here, the term abstract means the process which is invisible, but it performs a logic. Formal language. It is defined as the set of mathematical rules considered as an input to the automata or a computational machine. In simple words, the formal language is a set of symbols used to form a valid strings. These strings are given as an input to the automata or a machine. Next, automata. An automata is an abstract mathematical machine or a model of computations that process a formal language. Let us consider the process implemented through automata with the input as a formal language, deciding whether the output is valid or invalid. The validity of a output will be observed in the acceptance state and invalid nature of an output will be observed in the reject state. It means that the automata, which is a computational machine, will implement the logic through the formal languages as an input string and observes the output whether it is valid or invalid. If the input string contains the set of characters which belongs to the language, then the logic is implemented and it will throw the valid as an output. If the set of strings are not belonging to the language, the output is thrown as invalid. Basic concepts of formal languages and automata theory. Initially, alphabet. It is defined as the finite, non-empty set of symbols. Here the term finite indicates countable. Sigma is equal to 0, 1 indicates the two input symbols 0 as well as 1, which is considered as a binary alphabet. And sigma is equal to A, B, so on till Z. It means that it is a lowercase English alphabet which is countable in nature. Here we consider 26 input symbols. That is the reason the alphabet should be finite. And sigma is equal to the set of symbols which are special character symbols. Next, string, which is denoted by W. It is defined as the finite sequence of symbols taken from the input alphabet. Now let us consider the following example. For sigma is equal to A, B. It means here we have considered only two symbols. The strings can be composed with those two symbols such as AB belonging to this input symbol sigma, BA, BBA, etc. Next example, sigma is equal to 0, 1. It means that the strings can be composed only from these two symbols which are either 0 or 1. So the sample strings we have considered is 0, 0, 1, 0, 1, 1, 0, 1, 1, 0, which are composed only from the two symbols belonging to the sigma. And the next alphabet we have considered is the integer alphabet starting from 0 till 9. Then the composed strings which are 0, 1, 2, 2, 9, 1, etc. belongs to the input alphabet sigma. For example, if we consider the sample string 0, 1 star, here the input 0 belongs to sigma, input 1 belongs to sigma, but star is not belonging to the sigma. Here we consider the sigma value as 0, 1, but the string is formed as 0, 1 star. The symbol star is not defined in the input alphabet sigma. Thus, it is treated as invalid string. Length of a string denoted by modulus of W. It is defined as the number of symbols forming a string W. Here, let us consider the two strings W1 is equal to ABBA. Here we consider four input symbols A, B, B, A. Thus, the length of a string W1 is taken as 4. And the next string W2 is equal to 0, 1. Here we consider two inputs 0 and 1. Thus, the length of a string W2 is taken as 2. Now let's discuss about empty string. It is denoted with the symbol epsilon. The empty string is defined as the string with no input symbols or simply 0 symbols. If any input string contains no input symbols, then we call it as a epsilon. It is indicated by the modulus of W is equal to 0. It means that the string W contains no input symbols. Let's discuss about language. It is denoted by L. It is defined as the set of strings which are formed from the input alphabet sigma. Given the input alphabet, the combinational strings which are formed through this particular alphabet is considered as a language. For example, in our English language, we'll be forming n number of input strings which should be defined or which should be composed only through the English alphabetical sets, which are finite 26 character set. In the similar way, if sigma is equal to a comma b, then the languages, here we consider two languages L1 and L2. The language L1 is considered with the following strings. The sample string is A, BB, AB, AB, BBA. All the four strings are composed from the finite input alphabet sigma is equal to A comma B. Thus, the language L1 is belonging to sigma. Let us consider the language L2 here. The input strings we have considered in this language L2 are A, BAC, CAT. Here the input A is belonging to the input alphabet sigma. The input B is belonging to the input alphabet sigma, but the symbol C and the symbol T doesn't belongs to the input alphabet sigma. Thus, the language which is containing the invalid characters or invalid symbols which doesn't belong to the input alphabet is considered as the invalid language. Lean closure or star closure of a language. It is denoted by L star. It is defined as the set of all possible strings including an empty string from a input alphabet sigma. Now let us consider the following example here. Here we consider the input alphabet as the two symbols A comma B. Then the lean closure property is defined as the empty string epsilon, the string of length 1 A comma B, the string of length 2 AB, the string of length 3 BAB, so on till any length. Thus, it is written as L star is equal to the collection set of the string of length 0 which is L0, the string of length 1 which is L power 1, the string of length 2 which is L power 2, so on till the string of length n which is L power n. Positive closure which is denoted by L power plus. It is defined as a set of all non-empty strings from an input alphabet sigma. Now let us consider the following example. Let sigma is equal to A comma B. Then the positive closure of a language is defined as the set of all strings other than empty strings. It means we can consider the input of length 1, input of length 2, input of length 3 and so on. Thus we can write it as L power plus as the collection set of L power 1 which is the string of length 1, L power 2, the strings of length 2, so on till L power n, the strings of length n. Thus, we can relate the two closure properties as the lean closure L star is given by positive closure L plus the empty string epsilon. It means in the line closure property, we include the epsilon to the positive closure property. Power of an alphabet, it is denoted by sigma power n. It is defined as the set of all strings of a particular length that belongs to the input alphabet. Now let us consider the following example. Let us consider the input alphabet sigma as A, B. It means that the input language consider the two symbols either A or B of any length. Now let us move to the power sigma power 0. 0 indicates the input strings of length 0, which means epsilon. Sigma power 1 indicates the input strings of length 1, which means it can be either A or the input can be either B. Sigma power 2 indicates the input strings of length 2. It means that it composes the strings of all the probability of the input characters of either A or B. So the possible strings can be AA, AB, BA and BB. Thus, the power of an alphabet can be defined as sigma power n. Prefix of a string. It is denoted by WP. The definition is observed as it is the number of leading symbols or starting symbols of a string. Now let us consider the following example. Let us consider the input string as W is equal to ABCD. Then the possible prefix can be epsilon, A, AB, ABC, ABCD. Here, if we observe, the possible character can be the empty string which is epsilon, the first string which is with a single character A, and the next string which is two characters AB, and the third string which is three characters ABC, and the fourth string which is a string itself ABCD. Thus, the possible prefix can be given by epsilon, A, AB, ABC, and the entire string ABCD. Thus, in the prefix, we notice all the starting symbols in order until we form a entire string. Suffix of a string, it is denoted by WS. It is defined as the number of trailing symbols of a string. It means that here we observe the number of ending symbols of a string. Now let us consider the example of a string W is equal to ABCD. Then the possible suffixes of a string can be epsilon, which is an ending symbol which is empty string, D, CD, BCD, and the entire string ABCD. Thus the suffix can be observed as epsilon, last symbol D, ending two symbols CD, ending three symbols BCD, and the entire string ABCD.